folks, and welcome back to the workshop and welcome back to the Tesla hacking season. So it has been some time since we have hacked or reverse engineered, or call it what you will, a Tesla component and released an open source control system for it. On my bench for some time has been not one but two Tesla Gen 3 onboard chargers, and I've had a lot of other projects going on, health issues, play the violin, and it's been a while since I've been able to spend some time on it. But today we are hopefully going to demonstrate to you the operation of one of the first prototypes of our Gen 3 charger controller. Now, for those of you that may not be too familiar, the Gen 3 Tesla charger is 18.5 kilowatts versus the 10 kilowatts for the Gen 2. And additionally, the Gen 3 incorporates the components that were in the separate high voltage junction box as used by the Gen 2. Now, the bad news for us with the Gen 3 is that the logic board is not a removable component. You may recall on the Gen 2 charger, all you had to do to change the logic board was take out 5 or 6 screws, unplug a wire, pop the thing out, pop in the replacement, and you are all set. The Gen 3, however, makes that impossible. So that's been one of the kind of holding back factors that I've been spending a bit of time trying to work out what the best approach was. I didn't want to rush into it, but I guess when it comes down to it, the best approach is the simplest. So we're going to have a look now at the setup that we have on the bench here, where we have a European spec Gen 3 charger connected up with our custom wiring harness to our controller, and with our laptop here controlling that. Got an Arduino SavvyCAN system there just monitoring some CAN traffic for us, and we're hopefully going to be able to run this thing and put a little bit of charge into one of our Toyota Prius batteries. So that is if things don't go kaboom, because they do sometimes go kaboom. So anyway, let's go have a look. Alrighty, so on the bench in front of us here we have our Gen 3 charger. Now, just before we get into any of the details, it is quite a impressive piece of engineering insofar as that each of these PCBs that you see here is a 6.6 kilowatt battery charger just by themselves. It's quite impressive, and the European version has got 4 contactors in the back here that allow for connecting the battery directly to the charging port for DC fast charging. Now, so from the back to the front we have our high voltage junction box, our AC, in this case 3-phase neutral and earth would connect here. I've just got the 3 phases connected to the single phase power here so that I can put power into all 3 modules. We've got our DC outputs here, just on the left, positive on the top, negative on the bottom. There's a 100 amp fuse here for the high voltage system, and that kind of tells you the kind of power that our charger is going to be putting out here. So as we come down then here, these are our power modules, and down here at the very front, just bend you guys in here a bit. So down here in the very front is where the logic board would reside, and this 20-pin connector is where things would connect to the vehicle. Now, as you will see, Damien has been in here and has carefully removed at least part of the existing logic board. Now, you may ask me, why have I butchered this out of here? Well, the reason I went kind of full animal on this was I wanted to see if in any way it was possible to remove the board even in parts without having to, you know, cut the charger case or something further destructive. And yeah, I think I can pretty much confirm now that it's indeed not. Now, we'll have another video coming up for you guys soon, where I will show you how to connect up to the phase modules without having to go, you know, crazy taking out all this stuff. It can all stay there. But in order to learn that, I had to butcher. So, now, what we have here is that each phase module has 8 signal pins that normally connect to the logic board. So each of them solders on. The logic board sits vertically in here and controls the 3 phase modules. And they're controlled by means of high-speed CAN at 500k and 2 3-volt level control lines. So very, very similar to how the Gen 2 charger power modules operate, and indeed the CAN message formats for controlling these are, so far that I have seen, I'm not going to confirm 100% the same, but we can definitely get things working here using the same CAN message format. So, question we got then is, well, why don't we remove or take the Tesla control board out of play here and go in to the phase modules? As you will see, the soldering here, where I have soldered a new wiring loom onto the 3-phase modules, and that comes out via this white multi-core cable here, and comes all the way over here, all the way over here, and goes into our controller. Now, our controller is built inside of one of these cinch connector ECU type housings, and the type that I chose has got 2 Molex Minifit MX150, or sorry, Molex MX150 sockets. There's a 20-way here on the left and a 12-way on the right. So how things operate is that the black 12-way harness here connects to the charger phase modules, and this grey plug here, which would be the 20-way, would connect to the vehicle. So what we are basically doing here is we are taking out the Tesla control circuit totally in this case, but as I say, I will show you how to leave it there and simply hook into the control lines. We're then running a wiring harness, as it were, out of the charger to our controller here, and our controller really. I'm going to have to get a decent tripod. Our controller is sending the necessary switching signals and CAN messages to the phase modules, and they're pumping out power. It's as simple as that. This here is just an Arduino DUI that we're using for monitoring the traffic on the charger power module CAN bus at the minute, just for diagnostic purposes. That's actually not needed, nor is the USB here. That's just for programming and monitoring. So everything would be normally enclosed within this housing here, and then that's it. That's your charger functioning, basically. Alright, before we get into powering up the charger, I want to address one thing that I just know is going to come up in the comments and various other locations of discussion relating to this approach to controlling the Gen 3 charger. So, and that is, why am I not just using the original Tesla control board? Okay, so there's a number of reasons for me to have taken this approach that I'm taking here. The first is the necessary signals to make the charger function as it would have in a normal car, be it a Model S, Model X, whatever, are not available. You know, they're just not open source. Nobody has released the CAN messages and things like that. So, okay, well, why don't I just reverse engineer those from a CAN capture? Yes, I probably could. Would be quite a bit of work. But let's just say that I could magic that into existence. And we now have the CAN messages that logic board needs in order to function. Next up, we then have to deal with things like high voltage interlocks, enable signals, all that kind of thing now. Yes, again, they could probably be figured out and made to work. So, magic that into existence. Now what have I got? Right, okay. Now I have a charger that, okay, I can probably send some current commands to it, but I'm not going to be able to do anything else with it but use it as it would have been in a Model S, with a similar voltage, battery, and similar control scheme that they employ. So that's why I've gone down the road of, yes, it's more hardware, it's more physical work to make up a little harness and solder that into the charger. Yes, it's doing modifications to the charger. Yes, I know. But here's the upside. Now, we can control the charger with a friggin' Arduino program, okay? And even a muppet like me can manage to program Arduino. And we can get it to do pretty much anything that we want it to, okay? Recently, some of you may know I've put a Gen 2 charger into my E39 project, which has a nominal 192 volt battery. And that has brought with it some of its own issues that have required software changes to accommodate that. If I was just using a Tesla logic board, number one, if I tried putting it in a car with a 192 volt battery, it would just sit there and say, the man from Elon Monte says no. Okay? So that's why a custom, open source, hackable, modifiable control system is, for me at least, the way that I want to go with my Tesla components amongst other ones. Now, that is not to say that it's the best way. It's the best way for me, may not be the best way for you, and it's up to you to choose what control mechanism, vendor, operation, whatever that you want in your car. So, enough talking. Let's see if we can get this thing to either charge the Prius battery or fault out or explode. I don't know. Let's try. Oh yeah, and the odds on a Tesla Gen 3 charger charging a Prius battery with its own control board, I doubt it. Hey, prove me wrong. Show me a Tesla Gen 3 charger charging a Prius battery with its own control board. Why not? Okay, let's get to it. Alrighty, so right now we have our high voltage battery connected. I'm using manual control mode on the controller, so I can start the charging process by sending S over the serial terminal and terminate it by sending O. And I'm manually then switching on the mains power at somewhat the appropriate time. That way the power modules start up and deliver power. Obviously in EVSE mode, the controller would be taking care of that for us. So without further ado, let's go charging. So let's go S for start and enter and mains on. Oh, here we go. DC current. Yes, we have DC current on all modules. So I'm showing 5 amps going into the battery at the minute. Hoping you can see that. At the minute I'm asking each module to give me 2 amps, so we're probably you know, I can't really put much more than that in. My battery's at 220 volts at the minute. Each module is putting in about, you know, some of them are going to between 2 and 1.8 amps, because I have no cooling or anything else on here, and I don't have very much mains power. I've just got a 13 amp socket. So we are switched on. Let me try and show you guys the computer screen here. Don't know if this will come out at all. Let me turn off the light here. So we've got, yeah, about between 1.8, 1.7, 1.9, 2 amps, at about 222, 223. Total DC current, yeah, about a little bit high, maybe about 5.8 amps or something like that. I've got my set point at 250 volts, my termination at 240. We're not going to get there because I'm going to be turning off soon, as I say again, because we've no cooling here. But pretty much we're pretty much charging, folks, and our temperatures are fairly low at the minute. All 3 modules are enabled, and we have no faults on any of our modules. AC current about 1.8 amps on all 3. Let me just verify that quickly here with the clamp meter. There's my AC current. Yeah, I've got 5.8, 5.9 amps RMS AC coming in, and I've got, yeah, I'm down to 4.7 amps now. Might be limiting there just on temperature or something like that. 4.8. So okay, I'm going to stop it at that. I'll just turn off our mains, and we'll see then very quickly the modules will drop into a fault state here as the mains power goes away, and we can turn them off by pressing O. And that's it. That is our Gen 3 charger charging. Let me get you some light. It's our Gen 3 charger charging with our controller. Alrighty folks, I hope you've enjoyed this one. I certainly have. It's great to have another Tesla component working, in particular such a powerful battery charger. This one here is being shipped to a friend of mine. He's going to be putting that in a car. I have a US spec one here on the shelf that is going to feature in the next video. And in that video I will be showing you how to wire up the harness, as I say, without having to go chiseling out the board and all this nonsense. So, that's it for today. Don't forget to like, share and subscribe. Check the links in the description for Patreon and PayPal in case you wish to financially support any of this crazy stuff. Also in there you'll see a link to my GitHub where you can download the design for this thing and build your own without giving me any money. Oh, that's kind of stupid. Oh well, I am stupid, so hey. Right. Also there'll be a link in the description to the new Open Inverter forum, so do visit that and sign up for an account and you can interact with me and Johannes and other people. Right. And oh yes, and most importantly, there'll be a link in there to my web shop where you can buy this stuff. Yeah, go on. Give me cash. Okay. Right. So, until then, happy Gen 3 charger charging.